wanted to introduce the person who will be speaking today. So it's Prentice, and he'll be talking about a more philosophical, does mathematics exist? So without further ado, here's Prentice.
Truth be told, I'm a little bit amazed by this turnout. I was kind of expecting that something more this obscure would be 2-3 people tops. But anyway, all joking aside. So the whole premise behind this issue is basically, does mathematics exist in the universe? Is it inside our own heads? You know, we see math around us, and the question is, where does it fit? As for why this question, well, as I said, there's an ongoing debate right now. The Platonists and some physicists have been saying that the universe is inherently a mathematical model. Max Tegmark, in his 2008 paper, The Mathematical Universe, states that our physical reality, our external physical reality, is inherently a mathematical structure. He says that all the work that we've been currently doing in physics is effectively attempting to model one version of mathematics with a less precise version of mathematics. And as we get closer to the grand unified theory, we're trying to get rid of more and more baggage that's associated with language, until we get to something that is just a pure mathematical structure that eventually everything else can be derived from. Psychologists and neuroscientists, on the other hand, are saying that mathematics is actually evolved from our interactions with the environment. It's inherently part of our neural structure, and the only math that we can that exists is what we can comprehend in terms of our own brains. There's plenty of examples in favor of the side of mathematics being in the outside world. Wigner, in his paper, which is actually this very title, refers to the unreasonable effectiveness of mathematics in the natural sciences. There's plenty of examples of geometric patterns in mathematics manifesting in the outside world, one of which is the classic quote which I posted here regarding the double spirals of pine cones. Each of these patterns, as they go up, will become another number in the Fibonacci sequence. There are plenty of other geometrical progressions. The Fibonacci sequence itself shows up in flower petal arrangements, the insides of fruits with their seed distributions. Sunflower seeds are posted very similar in patterns to this in the way that you see the seeds emerging from the center of the flower. Even the ratios of our own bones going up from the finger to the arm are actually Fibonacci numbers in terms of their size and length. But no, I mean, this is according, of course, to Parveen, a particular math nerd who basically compiled a lot of this stuff for our relative viewing and amusement. There are also examples of mathematics being used to predict things outside of our field of regular experience. For example, while in several thousand years ago we may have known about the movements of the inner planets, Mars, Jupiter, Venus, and those ones that we see them in the night sky, most of that was plotted by epicycles and stuff like that, which wasn't very accurate. But once we actually started observing our outside world at the time of Galileo and at the time of Newton and developing calculus, we were able to finally start applying math to areas that we had never seen before. For example, there were perturbations in Uranus's orbit that when a scientific husband and wife duo started applying Newton's laws, they actually were able to eventually discover, with better telescopes, the new planet Neptune. The same process was repeated for discovering Pluto. Of course, once abnormalities regarding perturbations of Pluto's orbit were done, they couldn't extrapolate to a new planet, so of course they had to bring up something new, and Einstein's theory of relativity was evolved from that and other errors in planetary movements and difficulty reconciling that with Newton's formulas. There's also plenty of examples in biology of being able to, there's entire fields of mathematical biology talking about group dynamics, how exponential population growth, how species interact with each other. A lot of this is inherently mathematically modeled. Quantum mechanics had unique predictions which were of stuff that we never experienced. The EPR paradox is a classic example of this. When Einstein, Rosen, and Polanski brought this up as a way of showing that they brought this up as a way of trying to falsify quantum mechanics by saying that non-locality shouldn't be doable. Then they later confirmed quantum entanglement in the laboratory, and hence we have mathematics predicting something at a scale which, well, we're not evolved to see, for lack of a better word. So this would be evidence of the mathematics being inherently in the outside universe and us discovering it. How many people, by show of hands, have seen The Man Who Knew Infinity, that new film about Ramanujan? Okay, Do you guys remember a quote from G.E. Hardy before, when he was presenting the petition to make Ramanujan a member of the Royal Society? He said that mathematics was there for us to be discovered. This would be an example of why mathematics is there. There's also even some work about mathematics predicting how our behavior works. Contrary to what people would prefer to think, that we have a greater degree of free will, there are certain of our behaviors that are inherently mathematically predictable. Such as this heteronormative model, which describes how relationships work. Basically, Hannah Fry, an analyst working out of London, used this formula to quantify the work by John Gottman. The formula relates to how wives and husbands interact based on the interplay and the influence each partner has on the other. These particular formulas predict various things, including that a low negativity score will actually mean that relationships are more likely to stay together because of the fact that the influences are much higher. As in, people are willing to talk things out, they're able to bring things out on the table, and with the greater degree of interaction, relationships are more likely to survive. This model is and other work tied to it actually will predict the likelihood of a relationship surviving, according to Dr. Fry from her TED Talk. Now, of course, there are some, oh, I was supposed to save that. And of course, there are some predictions which come out of the idea that our universe is inherently mathematical. Tegmark's idea actually proposes a whole slew of different concepts regarding our universe. The first one is that there will be a grand unified theory which is baggage-free. He predicts that the ongoing descriptions of mathematics that have been so successful in the sciences will continue. It is a falsifiable prediction, but one that is not remarkable. And there is talk as well about descriptions of how particles and interact through the space-time dimensions. And out of this, there's even things predicted called a level 4 multiverse. From this description here, basically levels 1, 2, and 3 are the standard models you hear about in sci-fi or in theoretical physics. Level 4 is the idea that if a grand unified theory does manifest itself, it will not describe all of existence. It will simply tell us the mathematical structure of the universe we are currently in and help us distinguish our universe from other different mathematical structured universes. There is a way to falsify this. One of the things that such a grand unified theory would do, if our universe is inherently mathematical, is that it would be to a certain extent deterministic, which means that such a grand unified theory would actually supersede quantum mechanics and be able to describe both the position and the behavior of particles at the subatomic level. To quote Dr. Tegmark directly, a convincing demonstration that there is such a thing as randomness, as opposed to just events that grow up epistemologically towards uncertainty, in the laws of physics, would actually refute the MUH. So it would literally refute the mathematical universe hypothesis. So there is a way to falsify this claim. However, there are, sorry, that slide's actually a little, I'll just go back, that slide is not relevant yet. But there are some problems with this particular work. Number one is that it doesn't necessarily, well, while this shows that mathematics is connected to the outside world in terms of how it describes the outside world effectively, it doesn't reveal how the math is connected to the outside world. It doesn't show a causal mechanism for why mathematics is so descriptive of the outside universe. Presently, various forms of this, like the level 4 multiverse, are untestable, like all other versions of the multiverse are. Especially the falsification that I said about regarding demonstrating true randomness is not likely because there are too many grand unified theory candidates. String theory, loop quantum gravity, twistor theory, all of which are in the same position of being untestable at the present time. So it doesn't look like we're going to get a grand unified theory anytime soon. Now, as for the neurological model, Rafael E. Nunez is a psychologist who wrote the book Where Mathematics Comes From. He talks about an embodied theory of mathematics, that mathematics is tied very much to our experience of the outside world, is tied directly into the brain, and there's basically that the only math that can exist is that which the brain can comprehend. A couple of quotes regarding the idea of the Platonism. Science alone can neither prove nor disprove the existence of Platonic mathematics, just as it can neither prove nor disprove the existence of God. The perfect forms are if they're out there, are completely incomprehensible by the human brain, so why should we even bother for testing them? They also say that with regard, their answer with regards to how mathematics works in regards to physics and other sciences, all the fitting between the mathematics and the regularities of the physical world is done within the mind of the physicists who comprehend both. The mathematics is in the mind of the trained observer, not in the regularities of the outside world. They proceeded to go on by saying things like, real numbers are not actually out there in the outside world, they're just a naming system that we came up with, etc. Ongoing, there are Nunez, etc. Where did I put those? There they are. Nunez proceeds to go on and actually explain where particular sections of symbolic logic and various other parts of the mathematics are tied directly into the body. For example, these four examples of the rules of inference here. For those, just a quick show of hands, does everybody remember what these rules are from their first year discrete math? Or do I have to put them up on the board? Show of hands for how many remember? Okay, good, then I won't have to put these up on the board. But basically the thing is that for each of these is tied to the concept of containers. That the physical containers and that the relationships between an object being inside the container and outside the container are how we process these rules of inference. For containers, for every object is either in the container or out of it. For categories, the same thing. If an object is in container A and container is in B, the next is in B. Hypothetical syllogism, well, you get the idea. According to Nunez and others, these particular models are tied directly to the motor cortex of our body. Basically, by having understanding spatial relationships and where these things are, is basically what gives us our basic rules of inference, not just regarding physical objects, but extrapolating to numbers, classes, sets. Everything from there is extrapolated directly from our physical experience of the outside world. Unfortunately, why rules such as disjunctive syllogism, addition, simplification, conjunction, and resolution were not covered by this container schema is beyond me. I really wish they would have expanded on that. Of course, let me see here. There may be, there are as well other aspects of how this is tied to the environment. For example, the concept of negative numbers, according to the neuroscientific community, is actually tied to mental rotation. This is tied to the visual cortex of the brain as well as a bit of the motor concept. And that basically, if you imagine the numbers on the numbers on a line, that the way one transfers between 1 and -1 is simply by imagining a 180 rotation along the line in real space. With regards to arithmetic, this metaphoric blend of source and target domains associate the natural numbers with a huge range of experience in the real world. This is the basis between the basis of the link between the arithmetic and the world as we understand it. This is also tied to how we understand things like classes, etc., as we'll get to in a moment. They also claim that Boole equivocated numbers with classes, addition with the union symbol, multiplication with the intersection symbol, and so on. Basically what Boole did in order to be able to develop the beginnings of propositional logic was to simply map arithmetic onto the branches of mathematics pertaining to classes, and this was later extrapolated from classes to propositions, and then propositional calculus was formed after this. Unfortunately, there's also some claims regarding real reasoning includes phenomena like categories and other stuff like that. Symbolic logic is nowhere near, no matter how sophisticated in its present form, is anywhere near characterizing real everyday human reason, contrary to what a number of symbolic logicians and pure mathematicians might tell you. No matter how sophisticated the formal logics get, they remain mathematical tools created and understood by human beings. And despite the fact that even though the neuroscientists admit that a lot of this stuff, including in graph theory, it has applications to computer science and to economics, they still say that real reason is too complex for symbolic logic to master. Again, this is just what they're claiming. Go figure. Now, of course, the neuroscience of the brain, there are, of course, some problems with this. And this is the case of mathematical induction. They also claim that there is a neurological basis for all metaphors of infinity. Limits, asymptotes, mathematical induction, even the processes, the epsilon delta proofs, are tied to a single neurological process which extrapolates all versions of infinity. The process they talk about here is that the stage 1 result from the initial state of the process. This is referring to what they call an iterative process that just goes on and on. So eventually, any mathematical induction, whether it be an idea about the natural numbers or the idea from graph theory that any tree with n vertices has n-1 edges, would automatically extrapolate to a limit or an infinity. Again, I'm not entirely sure how accurate that is, but yeah, they claim it's even for the basis of the epsilon delta proofs. The problems with this particular cognitive model are basically it fails to address the predictive power of the scientific method that was mentioned earlier. How is it that we are able to establish this link to phenomena that we have no concept for? How is it that we are able to predict quantum spin, or at least be able to describe the spin positions of electrons or protons or quarks, which we have no direct experience of in our evolutionary environment? We are not evolved to see these things. We see the macroscopic level. Why is it that math that we've evolved is still able to describe this stuff down to a near perfect T? And secondly, it fails to explain why the brain evolved this in the first place. I mean, I was just chatting with one of the members of our audience here a little while ago, and he proposed the idea that logic has, given us all the technology, etc., so has become evolutionarily beneficial in the last 150 years. But the potential for our brain to do this has been around for thousands of years. There was a man by the name of Yu Hui from 220 AD to 280 AD in China, who was working on very early versions of differential and integral calculus. So why did our brains have this in our heads for this long period, and where was the evolutionary benefit for the entire of human existence? Yeah, but yeah, so something of course went terribly wrong in the process of the evolution, but that was just a slide I decided to toss on there for a joke. Anyway, so the question is, the falsification of the cognitive model would be required to prove that mathematics is not in the outside world. We have to prove that it really is in our own heads. And falsifying that idea is not really doable for reasons that we already mentioned earlier. We can't falsify the grand unified theory, we can't falsify the randomness thing, so we're kind of stuck for the moment. Curses, foiled again. So the question is, where do we go from here? I believe this speaks for itself. But for those of you who would like a further explanation, what do we do in the meantime? Oh, whoops, back. I forgot that I put that on cue cards. Anyway, basically the idea is from here that there is a simple test that we can... there is a simple test, and this is the reason why the aliens are mentioned, is that our environment is all interconnected. We have, all life on the planet has roughly the same basis for DNA, the same biochemistry evolving it. And we've known from chimpanzee studies and studies with other species that the same basic number sense is involved in lesser species compared to us. The problem with testing against any other culture or group in our environment is that they're all from the same environmental process. So the only thing we'd be able to say is that math was tied to our own brains, or that math was tied to the environment of planet Earth. The easiest way that I can see of resolving this question of math being in the outside world or being part of our own brain is to wait until we get first contact with our first intelligent extraterrestrial species. We proceed to ask them, can we see your math textbooks? And if they start, and if we start seeing that the only differences between the epsilon delta proofs or mathematical induction as we see them and as they see them is purely symbolic at the surface level, if the underlying axioms and chains of logic, of deductive logic, which were used to arrive at the math, are 95% or more similar, that might be an indication that the inherent rules of mathematics are somehow tied to the outside universe. On the other hand, if we discover that, that they started using different axioms or widely differing chains of logic and processes of logic to arrive at the same conclusions in their physics that we did, then we could say that the mathematics that we've developed is a tool of our own imagining, or a tool of our own evolution to cope with the outside world as we see it. There are some arguments for both sides of this issue, number one of which I was talking to another member of the audience at the beginning of the conference, And they were commenting about one of the issues about that we don't even have a classic agreed upon system of notation. I mean, we do for some symbols, but suppose that, for example, doesn't have a symbol for its own use that's consistently identified or agreed upon across the board. We've only gotten rigorous in terms of our actual proofs within the past 150 years or so. So it's entirely possible that the ways that aliens work with mathematics may be widely different and may actually prove the neuroscience model after all. But again, honestly don't know whether one way or the other. What do we do in the meantime? I argue that we shelve this debate for now. I mean, much as these philosophical musings on mathematics are fun to explore, and the possibilities of, well, you know, do we continue looking for a grand unified theory or trying to delve into the deepest reaches of symbolic logic and trying to figure out the root of a proposition to figure out, you know, whether or not this stuff is, you know, to figure out why math works. This is all well and great. But if it doesn't tie us to the practical physical world, if we do not have a way of testing this and then applying those predictions to something new that we in turn can test as a new theory, it's not really relevant to the scientific process. So I would recommend until we can test this, shelve the debate for a little while longer. Anyway, that concludes my talk. I have references at the end for anyone who would like to take a look at them. And in the meantime, are there any questions? Yes, Peter.
I would like to ask the question about this non-standard analysis. Maybe there is someone in the audience who could answer this. So non-standard analysis seems to be related to the failure of our eyesight and our touch. From this we extrapolate and we figure out that there are infinitesimally small numbers which are taken well. So for every real number, it is when for every real number one can find an integer, so that when we multiply the number by that integer, we shall get a number bigger than 1. Infinitesimally small numbers are such that this integer does not exist. So infinitesimally small numbers are kind of, are they creation of our brains, or are they dictated by something from outside? And I would like to mention yet that non-standard analysis was the standard tool of Leibniz. He was dealing with calculus without having exact theory of Cauchy sequences of real numbers, of Dedekind sections, yet he had intuition about non-standard analysis that allowed him to do a lot of analysis. Any opinion about this? Is this creation of our brain, or is this some external influence, or on every planet this will be discovered? What do you think?
Well, one thing I think that even down to just the general idea of real numbers is not necessarily something that's physically part of the world or necessarily found on like other planets.
Misnomer. They are not real.
They're not real at all. And so these infinitesimals just going any further. Why even think real numbers? Our world is not even continuous when you go down to the quantum level. So I'd say it's just creations of our own mind, but that doesn't make it any less of a necessarily universal mathematical truth derived from certain axioms that's useful in terms of other things.
I think that's the wonderful thing about philosophy itself, is it is a dialectic, and we have lots of time to be discussing this. But unfortunately, so without further ado, I'd like to get a round of